Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to waves and oscillations, and we're discussing about simple harmonic motion. And so far we have discussed about the important parameters of simple harmonic motion in the previous video, where we discussed about the basic representation, the mathematical equation for displacement, for phase angle, for amplitude, for time period, frequency, velocity, acceleration, all that. So in this video we are going to discuss about the basic, the cause of simple harmonic motion. Now so far we have defined simple harmonic motion, that it is a to and fro oscillatory movement of a particle about the equilibrium or mean position. That is simple harmonic motion, and any body which exhibits a movement like that, be it a spring, mass arrangement, simple pendulum, or whatever, wherever there is a to and fro oscillatory movement between two extreme points about a center or mean or equilibrium position, that is simple harmonic motion. That is the basic definition. But why it happens like that? What is the reason behind that? That we'll try to understand. Sorry. So here in the previous video where we discussed about the important parameters, we derived that the acceleration, the acceleration in SHM that we derived it as minus omega square y SHM, where y SHM is the instantaneous displacement of the particle and omega is the angular constant angular frequency. Now the negative sign here, what does it mean? This negative sign, it means that the acceleration is always in the opposite direction. The acceleration will always be in the opposite direction with respect to the instantaneous displacement. Suppose the displacement of the particle is towards the right, then the acceleration will always be in the opposite direction to the left. If it is to the left, then the acceleration will be to the right. So what it means is that there is something which is always trying to move the particle towards this equilibrium or center position or mean position. There is something which is always trying to bring it back to its original reference or equilibrium position, and that is called as the restoring force. That is called as restoring force, and this restoring force, let's call it FRF, F subscript RF, that is given as mass multiplied with acceleration of simple harmonic motion, where m is the mass of the object or the body undergoing simple harmonic motion, and that is equal to m multiplied with minus omega square y SHM. So again, this restoring force is again m square y SHM. Here also there is this negative sign. It means that the restoring force is always in the opposite direction to the instantaneous displacement of simple harmonic motion. Now here this parameter m omega square, it is called as k, the constant of proportionality, also called as the force constant of the system. this m omega square. So we can write it as minus k y SHM, the restoring force, this. Okay, so this restoring force, this is the reason why simple harmonic motion occurs, because whenever the particle, it moves away from the mean position or the center position, either to the left or the right, the restoring force again tries to bring it back to the mean position, the reference position, and in the process it again goes away from it, again it tries to bring it back here, again it goes somewhere to the other extreme, again it tries to bring it back. So this process continues. Okay, so this is the general expression of simple harmonic motion. Any system which is under simple harmonic motion, that will follow this equation. So the general principle says that whenever a body is subjected to a restoring force which is proportional to the displacement, the instantaneous displacement from the mean position YSHM, and is directed opposite to that, in that case the body will always exhibit simple harmonic motion. So this equation is the general standard expression for SHM motion, simple harmonic motion. Okay, so in the previous video also we discussed about time period and frequency of SHM. Here also we'll try to do it in a different way. So we know that the force constant, we just expressed it previously, that force constant of the system K is equal to omega square m. So we can say that omega is equal to root over of k by m. Okay, root over of k by m. Now we know that time period t of simple harmonic motion is 2 pi by omega. So we can write it as 2 pi root over, when we do it by omega, it will become m by k, this time period, or we can call it 2 pi mass by force constant. And frequency is reciprocal of the time period. Okay, and that will be 1 by 2 pi root over of k by m, just 1 by 2 pi force constant by mass. Okay, so this is another representation, another way of representing the time period and frequency of simple harmonic motion. Previously, in the previous video where we discussed the important parameters, there we derived it or we calculated it as this. Time period is 2 pi root over of instantaneous displacement of simple harmonic motion and acceleration time period, and frequency was its reciprocal. But here we just included the mass and force constant, the two parameters which got added here, where we discussed the basic dynamics, the reason of simple harmonic motion. So we got an alternate way of defining the time period and frequency of simple harmonic motion. So any way you represent it, it will be the same value. Okay, we will get the same result. Okay, so here we discussed about the basic reason behind simple harmonic motion and the basic equation, the standard expression of simple harmonic motion. And any system which obeys this expression, where the restoring force is acting on the particle proportional to the instantaneous displacement from the mean position and opposite in direction as expressed by the negative sign or minus sign, that body will always exhibit simple harmonic motion, a to and fro oscillatory movement between two extremes about a mean position or equilibrium position. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.